2x, x, 1. So 2x minus 1 and x plus 4 would give us the plus 7x. So what's the domain of function g?
One half. Third.
So x cannot equal 1/2 -4. Make sure you put the cannot equal to part in that. That's the important part. Function h. What's our worry with square root functions? So we don't want complex numbers. So the radicand has to be greater than or equal to 0. So what's the domain here?
9/5 cannot equal. It can't equal 9/5.
That's a symbol from the problem. X is less than or equal to 5/9. Why is it less than?
We divide by a negative.
To solve it for x, we have to divide both sides by -9, which is going to make the other signs. All right, so function capital F of x, same idea. Radicand has to be greater than or equal to 0. How do we solve a quadratic inequality? What do we do first? Factor. How does it factor? X minus 2 and 3x plus 1 will give us the -5x in the middle. Now what?
Can't equal 1, 3.
Critical points in the sign graph. So what are the critical points?
2.
-1/3. 2. Zero at each critical point. Positive, negative, positive. Domain is x values less than or equal to -1/3, or x values greater than or equal to. So the sign graphs are going to pop up over and over again. A lot of the time dealing with domains. That's one place we're really going to see this. If x is less than or equal to 1, or 2x plus 1 if x is greater than 1. At this point, all we really know are those 8 basic shapes that we talked about and how to graph lines. So that's all we really know at this point. Over the years, I have tried many, many different ways to teach these. To me, this is the easiest way to see what we're doing. I am going to graph the 2 pieces separately. And then I'm going to come back and put the 2 pieces together onto one big graph. First function. F of x equals x squared, so y equals x squared. What does y equals x squared look like? Like that. But I don't want the whole graph. I only want the piece of the graph where the x values are less than or equal to 1. All right, so here's an x value of 1. Where are the x values less than 1? To the left. So I want to keep the piece of the graph to the left. and get rid of that piece. Next big question. Do I want to include this endpoint, so do I want to put a solid dot there? Or
Yeah.
not include it where I put an open circle?
Include.
Include it.
Dot, why?
Equal.
Because it's less than or equal to, so I want a solid dot there. Last thing I need to know for this piece is, what actually is that point? If I plug in 1 for x, what do I get for y? 1. So it's the piece of the square function that goes up to and includes the point 1. Second graph, y equals 2x plus 1. So what is it? What's that shape? It's a line. What's the y-intercept? 0, 1. What's the slope? 2. 2, right 1, right points together. But I don't want the whole graph. I only want the graph where the x values are greater than 1. So there's my x value of 1. Where are the x values greater than 1? To the right of that? That's why I only want to keep the piece of the graph that's to the right of that. Once again, at that point, do I want dot or circle?
Circle.
Circle why?
Not it.
Because it's just strictly greater than. Now, even though it doesn't include that point, I need to know what is that point. If I plug in 1 for x, what do I get for y? 3. It's that piece of the line, but it doesn't include that point 1. Take the two pieces and put them together on our graph over here. So that's the first piece. And that's the second piece. All right. Now, the reason why it's so important that we know what those endpoints are. If you guys go on and take calculus, in calculus we talk a lot about continuous and discontinuous functions. Without me saying anything else, do you think this function is continuous or discontinuous? Discontinuous. Why?
It's not
It
connected.
has a break in it. The only way we can know it has a break in it is to figure out what those two endpoints actually are. Sketch the graph, figure out which piece you want to keep, solid dot or open circle, what is the endpoint?